Okay, hello everyone. This is Walter Gordon, chair of the AIAA Niagara Frontier section, and I'm kicking off this webinar with Dr. Bill Barry, NASA Chief Historian. He's going to talk about some things that you probably don't know about NASA history. Quick little background on Dr. Barry. He's been the Chief Historian at NASA since 2010, worked at NASA since 2001, and before that he was a tanker pilot in the Air Force. KC-135s. So I'm going to introduce Dr. Barry now, and if you encounter any glitches, it's because this Zoom thing is being run by a retired tanker pilot and a retired C-130 pilot. So you might want to expect those. Bill, it's all yours.
Thanks, Walter. Let me see. There we go. So I'm coming to you live from the ISS cupola here. Well, sort of anyway. Can you see me there, Walter?
I can. It's a nice background.
Yeah. Anyway, I thought this looks better than my bedroom. So anyway, let me see if I can get my slides shared here. So there we go. How's that?
That looks good. Looks very good.
All right. Let's see if I can get these to advance too now. All right. So good afternoon, everybody. Let's get started. So NASA came into existence a little over 61 years ago on October 1st, 1958. And then just 10 and a half years later, in July 1969, 50 years ago last summer, NASA put the first boot prints on the moon. The last couple of years have been a pretty exciting and busy time for the NASA history program. Normally you might expect this sort of talk that the agency historian would recite for you a long list of accomplishments of things that NASA's done. But I thought instead of that, we'd start with a little video that my colleagues at NASA Television made up for the 60th anniversary of NASA. So let's see how this works. And I think, did the sound come through on that?
No.
Well, that's too bad.
The video came through pretty well.
Oh, well, the sound's pretty good. I'm not going to run it back and replay it again. But one of the nice things about that, the sound of that, is that most of the words you saw coming up on the screen were printed quotes of the voices in the background. And most of the voice that was in the background there is actually NASA's first administrator, Dr. T. Keith Glennon. And the audio, that audio was a message that he sent out to the NASA employees on October 1st, 1958, the day that NASA came into existence. It was his introductory message to the new people of NASA. Our mission, now is pretty much the same as it was in the past, just with new technology and new understanding. And he actually wrapped up that message and the message that you would have heard if you heard the audio with, we have a mighty big job to do. And that's still true because 61 plus years later, we're still continuing to explore, we're continuing to press the boundaries of aeronautics and space research, including human missions to the moon and eventually onto Mars. As NASA's chief historian for the last decade, I've answered a lot of questions, and in the process of answering those questions, I've learned a lot about largely unknown bits of NASA's history, and I've also gained some perspectives, I think, on what NASA's done in the last couple of decades. I think what I'd like to talk about today is click ahead here, is those things that you don't know about NASA history. So where do we start? Well, with 5 decades of time since the first moon landing, I thought I'd pick 5 things. And I picked these things not because some of them are sort of slightly obscure, but not just because they're obscure, but because I think they also shed a light on NASA's past and also our trajectory into the future. So the first thing, number 5 on my list, counting down like the TV talk show hosts do from the top, is that NASA's already saved the planet at least once. And the story actually starts before NASA came into existence. And it begins with 1957, when the British Antarctic Survey started making measurements of ozone and other things over Antarctica from their base down there. Now, you probably know where the story goes, but stick with me for a little bit here. The measurements that they got at their base were troubling, and over the next 20 years, from 1957 into the 70s, they realized that they were beginning to worry about the changes that they were seeing in the ozone layer over the Antarctic Peninsula there. The measurements were summarized in this 1972 report that I have on the screen here. Now, the concerns became big news a decade later in the mid-1980s, when scientists published a paper about the ozone hole in the magazine Nature, which is where scientists tend to break big news. And in that article, they laid out their concerns over the springtime loss of ozone that they had measured over the British Antarctic Space Station at Halley Bay over the last couple of decades. Now, on this map here of scientific stations in Antarctica, Halley Bay is, if you're looking at a clock face, it's about 11 o'clock, just above an orange star there, Belgrano 2, and it's facing on the Weddell Sea there, that big bay there in the upper part there. So the findings were troubling because, as I'm sure you know, ozone protects us from the ultraviolet light of our sun. And unfortunately, the scientists didn't know, what they didn't know about the ozone levels was whether it was just over that particular part of Antarctica or if it was part of a larger hole, and whether or not that hole would expand over populated areas. And if it did, there would be skyrocketing rates of skin cancer around the world. So they needed more data about what was going on. And this is where NASA comes in. Because as it turns out, NASA actually happened to have launched on the Nimbus 7 weather satellite a ozone mapping spectrometer. It's a little box on the bottom of the satellite. As you can see, here's a little thing labeled TOMS, Total Ozone Mapping Spectrometer. That little box there was a spectrometer to measure ozone, not over the Antarctic or Arctic regions in particular, but it was there to measure ozone for other reasons. But it will work for measuring ozone holes. So they started taking measurements over Antarctica with it to map out the ozone hole. And what they found was this. This is one of the first pictures from the TOMS measurements generated from data in 1983. And this got everybody's attention because that dark, the red spot is obviously the bad part, but the dark blue and black parts are also holes in the ozone layer, and they're getting awfully close to Australia there. So that got their attention a lot. Now, scientists who studied this stuff and looked at the chemistry of it thought that the ozone layer was being damaged by chlorofluorocarbons, CFCs. CFCs were a chemical that were widely used at the time in air conditioners and as the propellant, the thing that pushes out stuff in cans, spray cans like paint or hairspray or whatever you wanted. And then the second half of the 20th century, a lot of CFCs were being dumped into the atmosphere, inadvertently through leakage of those systems or through spraying them out of spray cans. So while there is evidence from the ground and space that was fairly convincing and troubling, it wasn't clear that chlorofluorocarbons were actually causing the problem, and people who made chlorofluorocarbons weren't convinced. So they needed evidence that of what the problem was. And here's where NASA comes in again, but not with a spacecraft, but with an aircraft. in fact, with 2 different aircraft. This here is an ER-2, the NASA version of a U-2 spy plane, but NASA also flew its DC-8 over Antarctica along with the U-2 in 1987, and they actually measured with the U-2, particularly up at high altitude, the interaction of chlorofluorocarbons with the ozone layer, and in fact proved that chlorofluorocarbons were in fact causing the destruction of the ozone layer over the South Pole. Now the danger of losing that protection over populated areas was so scary that countries around the world, based on this data, got together that very same year in 1987 in Montreal and signed the protocol on substances that deplete the ozone layer, and that restricted the use of chlorofluorocarbons, and eventually a couple of years later, the use of chlorofluorocarbons was banned. Now the good news part of the story is that NASA and a number of other organizations have continued to monitor the levels of ozone over Antarctica and the size of the ozone hole. And I'm happy to report that in January last year, where these numbers were released, that you can see here, this chart, this confirmed a fairly consistent trend that the ozone hole is in fact shrinking. That's the top chart. And the bottom chart is the minimum size of the ozone hole. That's going up, which is a good thing. The hole gets smaller every year. And studies have suggested that the world has avoided over 2 million cases of skin cancer by 2030. So, by a decade from now, we will have avoided 2 million cases of skin cancer thanks to these improving numbers. So you may not have known it, but NASA helped to save the planet. And that's just number 5 on my list of things that you probably don't know about NASA history. Now, another timely one that I think applies to health and medicine issues is that, in fact, NASA was a pioneer in telemedicine. The technology and procedures that you might use nowadays to see your doctor, telemedicine, is something that NASA helped to advance the technology on and the procedures and techniques on. But this isn't just a simple case of applying space-age technology in new ways. This development involves budget cuts, Native Americans, and earthquakes. But I'll start it with a chimpanzee. Now, you guys probably recognize that this is Ham, the chimpanzee, getting ready to fly on a Mercury Redstone 2 mission, the flight in January of 1961. That was the test flight before we launched Alan Shepard in May of 1961. And you'll notice that Ham here has a bunch of biosensors attached to his body. And in fact, the cables look like they're taped kind of uncomfortably to his right leg there. I'm not sure I don't want it to go that way. But that way they could, deliver medical information and things about Ham's body to the ground by radio. The same sort of thing was applied, of course, to astronauts. And here's Alan Shepard getting ready to launch on his mission in May of 1961. They, of course, had pre-flight and post-flight medical exams, but that wasn't enough for the doctors. They wanted to know how the human body reacted in space, which meant they needed to be able to monitor life signs while he was in space. So they wore a variety of bioinstruments, but the technology wasn't very well developed at the time. And so for Alan Shepard on his mission, he had 3 biosensors. One was the electrodes you can see attached to his chest there for measuring his heart function. They had a microphone in his helmet so they could measure his breathing rate, and they could tell from the sound levels. And they also had a rectal thermometer to measure his body temperature. The doctors also had wanted a blood pressure cuff and have readings from that, but they couldn't figure out a way to make the blood pressure equipment small enough to fit in the capsule and under the suit, wearable enough not to restrict the astronaut's range of motion, and also compatible with the data transmission system. So the medical folks, they didn't have a blood pressure system for both Alan Shepard and Gus Grissom when he flew a few months later. But by February 1962, they'd actually had a crash program to develop an effective blood pressure sensor, and that flew on the rest of the Mercury missions. Now, things got more sophisticated by the time we get into the Gemini and Apollo programs. This here is the set of biosensors that were worn by Apollo astronauts. This is actually a worn set that was donated to the Smithsonian. I'm not sure which astronaut this came from, but this is a set of biosensors from the Apollo program. It's in the National Air and Space Museum. And beyond landing on the moon, in the 1960s, NASA had really big plans for building space stations and for the human exploration to the moon and Mars. And most of that planning and development work was done in the 1960s under a program known as the Apollo Applications Project. Now, here's some drawings from one of the studies and plans that were made in the Apollo Applications Project. These are notional drawings of what a typical day might be on a large space station. And I'm sorry, the visual isn't really clear, but it's a kind of reproduction of a reproduction. But I'd like to zoom in on the bottom two panels because you notice in here that they've got recreation, and notice that the 4 members of the crew are playing cards and nothing is floating except the 5th crew member happens to be wandering through the recreation room, floating in space, although the cards and chips are still staying on the table. It's kind of an odd thing, but anyway. But the thing I want to point out is on the right there, you'll see the astronaut on an exercise bicycle and some medical equipment, because they assumed that these space stations would have medical system on board. In fact, the medical system was fairly complicated. Here's a drawing from that same report, which shows microbiology and biochemical and biomedical stations in that station. In fact, the plans for this had gotten so far down the road that the biomedical station there, the clinical area and stuff, had its own distinct subprogram within the Apollo Applications Program. It was known as the Integrated Medical and Behavioral Laboratory Measurement System. Now, if you know NASA at all, you know that we'd have like an acronym out of that. So it's IMBLMS or IMBLMS. And the IMBLMS program was had some very expansive ideas about what they would do in terms of having a biomedical program for astronauts on space stations and out onto stations on the moon, and then eventually when we went out to Mars. But about the time that this report, that these pictures came out from in early 1970, the Apollo Applications Project was continuing to be cut. In fact, the only thing that survives from the Apollo Application Program into the future is actually the Skylab program, which was originally meant as sort of a placeholder to get started on a large space station, but it wound up being sort of the end of the space station program, at least for a while. So IMBLMS and all of the advanced miniaturized remote technology with it was basically dead on arrival. Or was it? Well, in fact, about the summer of 1971, the Nixon administration was looking for ways to use existing government programs to stimulate the flagging US economy at the time. And the IMBLMS folks at NASA saw this call for ideas, and they realized that they might not be able to test and develop their medical equipment on an actual space station and develop the procedures to use it there, but they might actually be able to do it on Earth and have somebody help pay for it in the guise of an application program under this Nixon administration plan. So the idea blossomed into a collaborative effort between the Indian Health Service, Lockheed Martin, and the Papago tribe of Arizona. They're actually now known as the Tohono O'odham people, I understand. And I have a nice vintage 1970s film clip that gives the NASA pitch on the project, but since it seems like the audio isn't going from the video into the thing here, I'm just going to sort of skip through this here. The idea was that they had this thing called StarPack, which stood for Space Technology for Advanced Promotion of Advanced Healthcare, Papago Advanced Healthcare, StarPack. And NASA very nicely sold this program as an idea of, with this, as you would have seen in the video clip, a very complex system where they had a big van that drove around that was connected by radio and had radio transmitters that covered the entire Tohono O'odham Nation and allowed them to do lots of things. The advantage of it is that it allowed NASA to try out these techniques, and not just the hardware, to develop the hardware, make it smaller and more compact and more easy to use, but also to try out, how do you make these things work? How do you protect people's privacy in this sort of situation when you're transmitting medical data back and forth? What kind of protocols do you use for, transmitting data, and all those sorts of, complicated things that make a project like this difficult to do. And so that program became a very useful testing ground for NASA. as it turns out, NASA supported that program from 1977 to, or 1975 to 1977, and then it continued on its own into the 80s. But by that point, NASA got called on to do some other things. This is a picture of the September 1985 earthquake in Mexico City. It was a magnitude 8 quake that destroyed over 400 buildings and killed at least 5,000 people. And there were extended aftershocks. So the recovery from this was long and difficult for Mexico. And NASA's telemedicine was called in to help out. So they deployed the telemedicine system there to help deal with the surge of patients that were overloading the Mexican healthcare system. A year later, in the late 80s, there was a huge earthquake on a similar scale in Soviet Armenia. And interestingly enough, the idea of building a space bridge, a telemedicine space bridge to Armenia came about in part because NASA had the capability, but also in part because NASA had developed personal connections with Soviet medical staff through the Soviet-US cooperation under the Apollo-Soyuz test program. So this is a way to use that. And the Armenia effort not only enhanced international relationships, but it also improved, it improved the technology by proving that you could use the system to work halfway around the world simultaneously, that you could interface with different cultures, and that you could combine rapid ongoing changes in telecommunications, the new technologies that were developing in the 80s and early 90s. And also as the 90s come along, the internet, all these rapidly enhanced telemedicine capabilities in practice, and they were tested out by NASA in these various space bridges, first to Armenia, and then they did one to a major accident site that happened in central Russia. And then in the 90s, there's a telemedicine space bridge to Moscow to help out the former Soviet healthcare system, which was collapsing in the early 90s. And NASA was able to help out with some of that stuff. So now we have telemedicine on an actual space station, and in fact, those technologies and techniques were proven out, about 40 years later than originally planned, maybe on the International Space Station now. But thanks to advances in technology and the practical trials of telemedicine on Earth, processes and procedures were dramatically refined, and now you can go have a consultation with your doctor on your smartphone. And the crew of the ISS can work on sequencing DNA. That's what Christina Cook, the astronaut here, is doing in the picture. So NASA's been a big pioneer in developing telemedicine, and the software, if you will, the software and hardware that was behind that. Okay, on to number 3. Now, one of NASA's primary missions is to do fundamental research that's needed to advance technology. That's how we improve our space technology. And as with telemedicine, oftentimes NASA's doing the kind of work that's either too risky or too expensive for commercial companies to do. But NASA, with a small investment of your tax dollars, these days it's less than 1/2% of the federal budget, but NASA uses that money to help break trail, if you will, with technology. And then industry takes that research and convert it into new products and services. And this is something that NASA's been doing throughout its history. Starting with communication satellites, starting with weather satellites actually first. This is a picture of the TIRO satellite, the Television Infrared Observation Satellite. Now, this is actually a project that was started by the Army and was handed over to NASA in 1958 when NASA was created. And the first TIRO satellite was launched in April 1960. But images of weather systems from space were not originally thought to be of great value when the project was being developed. But as it turns out, people discovered that images of, continuous images of what's happening on Earth from space are really valuable to have. And now we have a whole collection of weather satellites around the planet Earth. The US weather satellites are under the operational control these days of NOAA, the National Oceanic and Atmospheric Administration. But NASA works with NOAA to both build those satellites and help launch them and get them operational in space. So the whole satellite weather system traces its roots back to Army and then NASA research in the early 60s. But communication satellites were also an idea that came originally out of science fiction in many ways, but NASA and the military, again, got right to work in the early days of space. And NASA's first communication satellite was actually a giant reflective balloon that's shown here in the picture, the ECHO satellite. This was first launched in August of 1960. This is a picture from a year before 1959 of an inflation test. They're doing it in a blimp hangar, and you get a idea of the size and scale of this thing by looking at the bottom of the picture. That's a car down there, and there's several people standing at the bottom. So this is a huge balloon that would be launched, folded up, and then inflated when it got into space, and then used to bounce radio signals off back to Earth. Eventually, within a couple of years, NASA was developing more advanced communication satellites and was working with two companies, Hughes Aircraft and AT&T, to develop private communication satellites that could sit over one spot on Earth, over the equator, and transmit hundreds and then eventually thousands and even more signals at the same time. Now, the big satellite you see on the left is NASA's Application Technology Satellite 3. What NASA did was it continued to build test satellites, application technology satellites, in the early 1960s to try out new things that then were fed into things like the two Hughes satellites you see in the forefront of the picture there. The one in the middle is Intelsat 2, and the one to the right is the Intelsat 1, the early bird satellite. And actually, the reason this picture was taken was because these were the three satellites that were used in 1968 to deliver the Mexico City Olympic Games to the rest of the world through television transmission through space. Nowadays, instant worldwide communications at virtually no cost is something we hardly think about. And the satellite communication industry is a $200 billion a year business. It's a pretty big impact, I think, on the world as we now know it. But you may be thinking to yourself, well, okay, that's great, but what's NASA done for us lately? It's a long time ago since we invented weather satellites and communication satellites. So what's next? Well, let's talk a little bit about the business of launching things into space. Now, the military and NASA got started on this as well, but we almost also killed it off at one point in the early 1970s. The plan was that the space shuttle, pictured here, this is STS-1, the first space shuttle launch. You can tell because it's got a white tank. There are only two shuttle launches that had a white tank, STS-1 and 2. The shuttle was going to replace all expendable launch vehicles, and that's why it was called the Space Transportation System, and why those missions were numbered STS, whatever they are. But after the Challenger accident in the mid-1980s, U.S. policy changed. The shuttle hadn't lived up to expectations, and expendable launch vehicles made a big comeback. But by that time, the Europeans had gotten annoyed at us at having to wait for things to be launched, and so they built their own launch vehicle, Ariane. And about that time, the Soviet Union was starting to come apart, and there were marketing and launch services on the cheap. So the U.S. launch industry actually got clobbered by not having a market to sell to, because most of the launch business, commercial launch business, went to overseas launch vehicles. And the U.S. industry was stuck with government and military launch contracts. There we go. But in the early 2000s, the then NASA Administrator Mike Griffin decided to do something about the launch industry in the United States, in large part in response to the complaints from a number of people who had ideas about how they could do it better. And so he launched what was called the Commercial Orbital Transportation Services, or COTS program. And this was a program where American companies were offered contracts to send cargo to the International Space Station using their own privately developed and operated vehicles. And to help get them ready, the COTS program included payments to those companies that if they reach certain milestones in the development of their rockets and capsules. Now, one of the original companies, rocket plane Kistler, didn't make it through the milestone process, which is how the process is supposed to work. Companies are supposed to prove that they were robust enough to make it work. But you probably know the name of the other one. That's a company called SpaceX, and this picture here is of the SpaceX Falcon 9 lifting off from Cape Canaveral in May of 2012 on their second demonstration mission of the flight to deliver cargo to the International Space Station. Since that time, SpaceX has delivered over 20 cargo missions to the space station in the last 8 years, and done a great job of it too. The other company, when rocket plane Kistler fell out, we still wanted competition in the program, so NASA went looking for another partner to do cargo delivery to the space station, and Orbital Sciences Corporation came out and decided they'd make a bid on it. So they built the Antares rocket shown here and the Cygnus cargo spacecraft. Both of those launched from the Wallops Flight Facility on the coast of Virginia. The launch pictured here is in just earlier this year, on February 15th, 2020. And this program's had some glitches, but this was their 13th cargo mission to the space station. And the company, it's no longer Orbital Sciences, now owned by Northrop Grumman because it's been bought and sold a couple of times, but it's been highly successful. Now, cargo worked pretty well. That seemed like a pretty good idea. So NASA applied that same idea of buying commercial services, not only just to deliver cargo to the space station, but to deliver our astronauts to the space station. This is a picture of the SpaceX Crew Dragon spacecraft undergoing final processing at the Cape earlier this month. This vehicle will be launched, planned on May 27th with astronauts Bob Behnken and Doug Hurley to deliver them to the International Space Station on the first crewed test of the Dragon spacecraft. Not only will it be the first U.S. launch to the space station from the United States since the shuttle was retired in 2011, but it'll be the first time that a private company has ever delivered NASA astronauts into space. And we expect that SpaceX will be regularly transporting astronauts to and from the space station. And SpaceX has announced that they've also got a deal to carry other paying passengers into space. And NASA thinks that's a great idea. That was part of the idea of the program, was to develop the capability to have multiple vehicles that could carry people, not just NASA astronauts, into space. Now, as with the COTS program, the Commercial Crew Program, also we wanted to have some competition in the program. So we encouraged another company, and Boeing company is building a spacecraft called Starliner to deliver crew to the space station as well. Starliner's had some issues recently, but here's a picture of the first Starliner crew. That's Mike Fink in the foreground, Nicole Mann, and Boeing and former NASA astronaut Chris Ferguson on the far end. They're in the Starliner simulator in Houston, practicing a mission. The Boeing companies announced that they're going to refly their test mission that didn't go so well late last year. So, but we still expect that they'll be flying crews to the space station relatively soon, and that next year or so we'll have not just one way to get cosmonauts and astronauts to the space station, the Soyuz vehicle, but we'll have three. We'll have two American companies with two completely different spacecraft able to deliver crews into space. And we expect that those spacecraft will be used to deliver other people into space as they need to be. So that's number 3 of my things you probably don't know about NASA history. Moving on to number 2, NASA has revolutionized our understanding of the universe. Yeah, well, yeah, probably you figured that out, right? That's probably not a surprise. But as I've been looking at things over the last 10 years as NASA chief historian, it occurs to me that oftentimes I think people just don't appreciate how much our understanding of the universe has completely changed in the last 6 decades that NASA's been around. Now, let's start with the first major scientific discovery, one that was announced. Actually, the anniversary of the announcement is tomorrow, May 1st, 1960. That's that there were radiation belts around the Earth. Explorer 1, our first satellite, along with Explorer 3, the second successful satellite. And again, this was a mission launched by the Army and JPL. But there's no reason to believe that there were radiation belts surrounding the Earth prior to this point. And so the Van Allen belts were a very big surprise. And in fact, at the time, people didn't realize that the sun, pushed anything out of it other than photons, light that hits the Earth. In fact, there are several scientists who proposed this idea that there was a thing called the solar wind, that there are particles streaming off the sun. But most scientists dismissed that idea, saying that if the sun had been spewing particles for billions of years, there wouldn't be any sun left. Well, the sun's pretty darn big, I guess, because the sun actually is spewing particles, and that's part of what causes the Van Allen belts. So now we know that the solar wind interacts with the magnetic fields around the Earth, and then it not only creates those pretty auroras that we can see in the North and South poles, but also the magnetic field that protects the Earth and keeps our atmosphere from being stripped away by the solar wind as it flows by. Now, outside of Earth, there was also a lot that we didn't know about the rest of the solar system. And in the late 1950s, I sort of remember this because I remember being exposed to this theory as a kid. But there was a theory that the planets had formed from the outside in. So the closer you get to the sun, the younger the planets are. And so the older planets are out there. So under that theory, that would have meant that Venus was younger than the Earth. But in the early 1960s, as the space age is opening, we didn't know much about Venus other than that it was about the same size as Earth, and it was covered in clouds. And under this theory, gee, it might be younger than the Earth. So this is the picture I remember seeing as a kid. People thought that maybe there would be dinosaurs on Venus because, in fact, it was like Earth. It was probably warm and swampy like a primitive Earth, and so it might have these dinosaurs. But our first space probes that went to Venus proved that Venus was, in fact, really warm. In fact, the surface temperature is about 900 degrees Fahrenheit, which is enough to melt lead and probably dinosaurs too. And then we found out that our sister planet was suffering from runaway greenhouse effect, which had an interesting implication on our thoughts about Earth's ecosystem. And the scientists like Carl Sagan and others who raised questions about both climate change and nuclear winter. Our understanding of Mars 60 odd years ago was a little more sophisticated than you see here this is a 1906 article from the New York Times, December 1906. It talks about the canals on Mars when that was a new idea. But this whole idea of canals on Mars and a dying civilization there was actually consistent with this theory that the older, the outer planets were older than the Earth and that they would be dying and aging. And although by the 1950s, we were pretty clear that there probably wasn't a civilization on Mars, it was a fairly widespread belief that, in fact, Mars had plant life, fairly substantial plant life on it. This is a still frame from one of the Walt Disney 1950s productions about space exploration, where they said that animal life probably didn't exist on Mars, but there was certainly plant life, and this is what they thought it might look like. Now, what we really know is that Mars was actually wet at one point. And this is an artist illustration of what Mars probably looked like in the early days on the right with water and an atmosphere, and what it looks like now on the left without that. And we now understand, based on recent things we've learned from probes orbiting around Mars, that in fact, Mars lost its magnetic field early in its existence, and unexposed, the atmosphere was stripped away by the solar wind as it flew by, which dried out Mars and took its atmosphere away. Now, the question people ask is, was Mars wet for long enough to develop life there? And that's a question that our robotic missions that are wandering around the surface of Mars, including the Mars 2020 rover that's about to launch this summer, that's one of the questions that they're trying to answer is, was there ever life on Mars? And that's a really interesting question. Now, what about the rest of the solar system? Well, when I was a kid, in the early 60s, we knew that there were big planets out there. Some of them had moons, but we expected that they were all so far from the sun that they'd be mostly frozen rock and ice. And based on that theory about the older planets getting older the further you get from the sun, that these big old planetary bodies were probably not very interesting. But when we went to go take a look as the space age began, we discovered with all these probes that went out there to take a look that, in fact, they were really interesting, a lot more interesting than we expected. There were volcanoes, flowing liquids on some of these planets and moons, and even moons of Jupiter and Saturn that had ice on the outside crust, but they had liquid water oceans underneath the ice. How do you have that way out there in the cold outer part of the solar system? And looking around in the outside of our solar system the last couple of decades, we've proven that, in fact, our solar system is not unique. And we didn't know back in the 60s that there were planets around other stars. We assumed that there might be, but we didn't know. But in fact, the Kepler Space Telescope that we just decommissioned looked at a very small part of the sky and found thousands of stars with planets around them. And Kepler's follow-on mission, the TESS mission, the Transit Exoplanet Survey Satellite, which is up in orbit now, is looking at about 90% of the sky rather than just a small part of it, and looking for exoplanets. And it seems that everywhere we look, stars have planets. So those billions of stars out there appear to have billions of planets. And that raises some interesting questions about one of humanity's biggest questions of all time, which is, are we alone? And, I haven't even touched on the other big and the most mind-blowing question yet, is where did the universe come from? Well, we now have proof, and the proof comes from this weird picture. Right? This is a graphic map of the data from the Wilkinson Microwave Anisotropy Probe. Okay, how many of you guys have actually ever heard of that Wilkinson Microwave Anisotropy Probe? Right? NASA flew this mission as a small mission in the early 2000s, and by mapping the microwave radiation microwave radiation from the early days of the universe, we were able to prove that, in fact, the universe originated in a Big Bang, and it happened 13.7 billion years ago. Now, you may think that, well, okay, so that was a theory that, and we all sort of know that that's true, but this is an important enough piece of work that the NASA scientist behind us, a guy named Dr. John Mather from Goddard Space Flight Center, won a Nobel Prize in Physics for this picture and the research that came with it in 2006. So it was a big deal. Okay. Finally, on to the thing I think is most interesting, number one thing on my list of things that you probably don't know about NASA history. And in honor of our 50th anniversary of the Apollo 11 moon landings last summer, I want to disabuse you of the idea that, in fact, there was no race to the moon. Now, many people thought in the 60s, in the 1960s, that if you asked them about it, that well, there may have been a moon race, and it probably started the day this picture was taken, which was in May 1961, when President Kennedy challenged the Soviet Union to get to the moon. Actually, challenged the United States to get to the moon within a decade, a clear challenge to the Soviets. But most people would, if you'd ask them about it, would say, well, you know, the Soviets did a bunch of stuff early in the 60s, and then they sort of dropped out, and they really didn't play along in the race to the moon. And in the end, we were only racing ourselves. Well, in fact, that's what the Soviets also said, is that the United States is just racing itself. But they were lying. There really was a race to the moon. The issue is that a race needs a competitor, and in the summer of 1961, there wasn't one. Right? From the Soviet perspective, they weren't interested in Kennedy's challenge, and in fact, they thought Kennedy's challenge was laughable. They believed that they were far ahead, and in terms of payloads they could launch, they were, but not really in terms of much of anything else, in terms of technology and numbers of vehicles that they could use to launch. And the Soviets also were getting mixed messages from President Kennedy. While he's challenging the American public to get to the moon within a decade, a month later, when President Kennedy met Premier Khrushchev in Vienna, he offered, in fact, that the United States and the Soviet Union should go to the moon together. And he made that offer several more times at speeches at the UN and other places. And on top of all this stuff, the mixed messages, the belief that they were far ahead, the Soviets also were worried about their defense issues, and they really didn't want to spend a lot of money on space exploration in the early 1960s. So they did a lot of sort of fancy one-off programs. So when does this race to the moon begin? Well, it actually starts in mid-1964, when President Kennedy is far from the scene. He's already dead in President Johnson's charge. Now, I want to show you this list. I'm sorry about the yellow boxes that obscure the numbers here a little bit, but if you look at this, this is a list from the annual report of the President of the United States on space activity, and the Appendix H every year has this list of space launches, and it adds on every year. This is the top of the list, and if you look at it, you know, the Soviet Union launches 2 satellites in 1957, but after that, the United States is way ahead in terms of numbers of things being launched into space up until 1967. Sure, the Soviets launched a lot of missions into space, but in fact, their program wasn't really much of a systematic space exploration effort as much as it was a propaganda effort to one up the United States. And they were very carefully studying what the United States was doing, figuring out what they could do that could have a good propaganda play, and then making very clever use of their booster rocket and a very talented and creative design team to make great propaganda. You know, clearly they were a nimble engineering program, but it was a really small program, a very thin program, and it wasn't really a program at all so much as it was just one thing after another. But by 1964, the United States actually is accelerating our capabilities and getting more effective at space. And as we finally build a rocket that's bigger than the Soyuz rocket that they were using, the first Saturn rocket launch was in 1964. And it became clear that President Johnson, unlike President Kennedy, was clearly very deadly serious about getting to the moon. The Soviets decided in the summer of 1964 to finally engage in the race to the moon. And the first thing they did in the summer of 1964 was start this program, the Zond program. This is a drawing from a Russian publication about the program. And the spacecraft is shown in the middle, but the flight plan is shown around it, where they would basically take a crew, send them on a free return trajectory around the moon and bring them back, so that they could claim that they had the first humans arrive in the vicinity of the moon. Fairly straightforward and simple program, and their goal was to do it by November 1967. and it flew under the name of Zond. And if you look at the next chart here, this is a list of the flights that were flown in the Zond program. By the end of 1968, they'd flown 10 test flights. In 1968, they weren't particularly successful until 1968, and then the September and November test flights actually appeared to go pretty well, and had some people in the West who were watching this program worried about it. But what we didn't know in the West was that, in fact, on both of those missions, the September 15th Zond 5 and the November 10th Zond 6 mission, both of them failed on reentry. One landed in the wrong place, and the other one, the heat shield burned through. So the Soviets weren't about to actually launch humans to the moon and lob them around the moon in December 1968, as was feared. And in fact, what actually happens is we launch Apollo 8, and for a change, the United States preempts the Soviets, scores the big propaganda points by orbiting a crew around the moon. There were some Zond missions that were flown after this, but none of them ever flew with a crew on board. Now, that's a pretty serious challenge, but the Soviets weren't settled on just that. They actually, in the summer 1964, when they started the Zond program, they also started another program to not just put a crew around the moon, but actually land a crew on the moon. And they built this rocket, the N1 rocket. There's some people at the bottom there to give you an idea of the scale. The N1 was the same size, effectively, as the Saturn V. They were within a couple of feet of each other in terms of height. And so they had a crash program to build the N1 rocket. And they made pretty remarkable progress. They went from basically 0 to 60 and built the design and approved it. And the first test launch comes in 1969. So about 4.5 years, they go from approving the program to actually doing the first test launch. Unfortunately, that first test launch doesn't come until February 1969, after Apollo 8 already got to the moon. And that rocket exploded 69 seconds after liftoff. And the United States' tremendous success with the Saturn rocket, just simply the Soviets couldn't keep up with that because they didn't have the time and the money and the effort to be able to do the test program like we were able to do. They did try again in 1969 with the N1 rocket in July, just before the Apollo 11 launch. They had another uncrewed test flight launched at night. This is a picture of that launch. You can see that at the top there's a bunch of smoke around the top. That's the launch escape system on the N1 rocket, pulling the capsule away. That would have had a crew on board if it had a crew. At the bottom, you can see the rocket looks like it's on fire. That's because the rocket engines were failing, and this rocket collapsed back onto the launch pad and had one of the largest human-made explosions ever as it took out the launch pad for the N1 rocket that it was launching from, and also the backup launch pad that was nearby. So the N1 program was just a little too little, too late. And you might think, okay, so they attempted to build a rocket that sent a crew to the moon, but they weren't that serious about it. And really, the moon race is over in December 1968 when Apollo 8 flies. But not really, because getting to the moon was really important to the legitimacy of the Soviet government, both internationally to prove that they were, in fact, ahead of the United States and that the communism was the wave of the future, and also domestically to prove, in fact, all those Soviet citizens who had to wait in line for bread in the stores and other things, that in fact their system was worth supporting. They needed to prove that that was still the case, and so the Soviets, and after the Apollo success with Apollo 8, they decided to have a crash program to still try and beat the U.S. to the moon, and they built this spacecraft, the Luna spacecraft, which was designed to land on the surface of the moon, collect the sample, and bring it back. The full spacecraft is on the left of the picture here with the blue background, and the picture on the right is a close-up of the upper part of that, which is the probe that would have launched off the surface of the moon after the sample was collected and put in that ball on the top and be returned to Earth. Pretty complicated mission. And they start the program in January 1969, and amazingly enough, they actually had the first probe built and ready to launch in June, and they launched it, and the launch vehicle failed. They might have been successful at bringing a sample back from the moon well before us if that had been successful. But they still weren't deterred by that, because they had another one of these lunar probes ready. They launched it on July 13th, 1969, and just 3 days before Apollo 11. And they named it Luna 15 because it actually got to the moon and was in orbit around the moon. But strangely enough, it sat in orbit around the moon for several days. The Apollo 11 crew arrives, lands on the surface of the moon, And this picture here is an article from the Washington Post the day that the United States landed on the moon. We were well aware of Luna 15 being in orbit around the moon, and we were concerned about what was going on. The Soviets actually did send some information to us about what it was doing. There was a fairly good amount of collaboration on that, and they were pretty good about staying out of the way of the United States there. But Luna 15 stayed in orbit around the moon until Neil and Buzz had walked on the surface of the moon, got back in the lunar module, and had a night's sleep, and were getting ready to launch off the moon. And then about an hour before they were ready to launch off the moon, Luna 15 fired its retro rockets to try and land on the moon. They delayed because there had been some technical problems, and they were concerned about the radar altimeter on Luna 15. And in fact, the radar altimeter failed, and Luna 15 crashed into a mountain on the moon rather than landing successfully. But if it had been successful, they would have gotten a moon sample back about the same time that we did, and they could have said that we did it more safely than you did, and the Soviet Union is just as good as the United States. So the race to the moon, it doesn't end until July 21st, 1969, after we'd already landed at the moon and had a box of moon rocks in the lunar module ready to come back home. So that's 5 things that I think a lot of people don't know about NASA space history, and I'd like to wrap it up there and leave ourselves some time for some questions here. So I'm going to stop sharing my screen.
Okay. Thank you very much, Dr. Barry. We're going to take questions submitted by text. There's a little Q&A symbol at the bottom of your Zoom box, and you can type questions there, and hopefully we'll get some and select some for answer. We have one so far, and this person wants to know your personal opinion of NASA's selection of the 3 companies that were selected to build the human landing system for Artemis today.
Oh yeah, just announced a couple of hours ago by Administrator Bridenstine. We're excited about the hardware being built to get us to the moon, and have a sustainable presence on the moon. So this is a great thing, and again, it's part of the same sort of strategy where NASA's trying to, rather than just run the space program by itself, to work closely with partners to do things. So we have 3 commercial partners that'll be building different parts of the system there, we're looking forward to working with them to build that hardware, test it out, and get humans back on the moon, and particularly to land on the south pole of the moon, which is what we're aimed at doing. You couldn't land on anywhere other than sort of the lunar equator with the Apollo hardware. This didn't have the capability to do that. But these will be more powerful systems with modern technology as well, but also a capability to land anywhere on the moon and put our astronauts and our hardware in various places to study the moon. So it's really exciting, and we're looking forward to that coming ahead.
Yeah, thank you. And the next question is, can you describe some ways that NASA is using and publicizing its history to inspire the next generation in engineering fields for space?
Yeah, sure. NASA's got a small but very energetic, I like to think anyway, history program. And we try to put out a couple of books a year. The last couple of years we've been busy with the 60th anniversary of Apollo in 2018, and then the Apollo 11 50th anniversary last year. So our production rate's down a little bit, but we put out some serious histories that are well researched by people. We normally do those like the military does under contract. Unfortunately, I don't get to write too many of NASA's history books myself, but we normally hire contractors, and what Steve Garber and I at headquarters do is we manage those contracts. We read the material, we provide feedback to people, and manage the peer review process on books like that. The last book we put out was actually a history that Steve wrote. So I had to do all the managing on that particular project, but Steve and a former member of our history office, who's now working at the Office of Secretary of Defense, and it's about how NASA's preparation for future planning, a group called the Decadal Planning Team in the 90s, really sort of set the groundwork that allowed the Bush administration to decide that we could actually execute a long-term human space exploration program, and that got announced in 2004 as the Vision for Space Exploration. And really, that's policies have changed a little bit back and forth, but really that sort of is the first big change where, the United States government has announced that our policy is to send humans back to the moon and onto Mars. That was a big step. And so this book is a policy study of how that happened. And it actually has won 2 awards. It won the AIAA History Manuscript Award. If you were at SciTech in January this year, you'd have seen Steve and Glenn Asner collecting that award. And also the Society for History and Federal Government, small but very active organization for government historians, presented it with their top book in 2019 on federal history. So we do that. We know not everybody wants to read books, so we also have other outreach. We have lots of things. We have a huge website at history.nasa.gov where people can find information. We have social media sites for those who are interested in that. So we have a NASA History Facebook page and a @NASA History Twitter account. Our NASA History Twitter account has over 910,000 followers. So it's a pretty popular site, and we like to think that we produce interesting material on there that people like to see. And our Facebook page is like 2.2 million followers. So we'd like to try and get out there and do that stuff. And a lot of history materials being highlighted on the NASA at Home site for those who are, in the current pandemic, trying to homeschool their kids. So NASA's been trying to make sure people have as much material as possible to do that. So anyway, what else do we have there, Walter, for questions?
Okay, we have another one. What are some recent accomplishments in NASA history that we, the listeners, are not likely to know about? Something really interesting that didn't get the press it should have.
Oh, well, there are lots of things that NASA does that, all of us inside NASA assume everybody knows about it. And frequently I'll, go home to visit family or relatives, and then they'll say, you did what? And I'll think, oh, well, I guess you didn't know about that. So it's hard for me to judge that, but I think some of the really interesting science things that we've been finding out from various astronomy probes, and also all the Earth science probes. NASA's got on the order of, I don't remember the number exactly off the top of my head, but it's on the order of 20 Earth observation satellites, and some that we do in collaboration with other countries as well, that we collaborate on, looking at the Earth and studying all kinds of aspects of it. So we have the data on what's happening with ice in the polar regions or elsewhere, or what the sea level is doing in various parts of the world, and what the temperature of the ocean is all over the planet. So that kind of stuff is really critical data that we need to have to understand what's going on, because the Earth is an incredibly complex system. It's not easy to describe, but if we have the data, we'll be able to understand things more, and that's what NASA excels at, and is providing the data for understanding our own planet as well as other planets. And to me, one of the interesting ironies of it is that much of the technology that we now use to look back at Earth, a lot of that was developed at JPL and other places to look at other planets. And Earth scientists in the late 70s and the early 80s said to themselves, we could understand Earth better if we have another planet to study. We can compare it to other planets as well, but we also understand Earth better. And so it's one of those odd spin-offs of planetary exploration, that we now know more about Earth because of the equipment we developed to study the other planets.
Okay.
I'm trying to answer shortly questions because I know we're running along, and
that's okay.
And I will never shut up if you give me a chance to keep talking. Anyway.
Well, this will probably be the last question because we have been an hour, and it's about going to Mars. Did NASA seriously consider going on to Mars after Apollo? And how far did that go?
Yeah, that's a really good question. In fact, we NASA History Office published a short monograph, about 50 or so pages of a thing called a few years back about studies that were done on Mars, and there were over 50 serious studies on how do you get humans to Mars done over the course of NASA up until when this was published, which is about 15, 20 years ago now, and we've done more since. And so Mars was seriously on the horizon. NASA in the 1960s had big horizons. They had a big budget, and people naturally thought, okay, well, we're going to use this Saturn V and this other technology to go out and do it. We invested all this money in it. Let's keep using it to keep pushing the boundaries. And so the budget, though, for future programs, particularly like the Apollo Applications program that I mentioned, was the thing that suffered in order to keep the Apollo program going. So it was always sort of being cut, and it wasn't clear how it was going to go. And as the bills for the Vietnam War mounted in the 1960s, and the bills for the Great Society under the Johnson administration mounted, the Johnson administration wasn't willing to commit to do anything else. In fact, Johnson basically said, "I'm going to leave it to my successor to decide what we're going to do in terms of space exploration in the future. We'll get to the moon, but that'll be the legacy I'll leave behind. But the next president will decide where to go next." And when President Nixon came in, he put Vice President Agnew in charge of a team, and they got together with NASA and they did a plan. And the plan they submitted, it was called the Space Task Group, which is confusing because there's the Space Task Group in the early days of NASA that is effectively what becomes Johnson Space Center. But this Space Task Group report had recommendations for what the United States should do in space exploration in the future. And basically it was, we can go to Mars in 10 years, we can go to Mars in 20 years, or we can go to Mars in 30 years, take your pick. I mean, it was very optimistic about, how much, what kind of goals the United States would pursue, and also how much money would be available to do that. The Nixon administration, the president himself, was really not interested in that. And so that idea get kiboshed, and they never really responded to this Space Task Group report. And in fact, the only thing from that report that got approved was only several years later, in 1972, when President Nixon finally agreed that we really needed to build a space shuttle to have a more cost-effective, what was believed to be anyway, a more cost-effective way to get astronauts into space, but not to get them out into deep space, but just into Earth orbit. Mm-hmm. So yeah, Mars has been on the planning horizon for a long time, and there have been serious efforts, mainly in the 60s. It kind of fell by the wayside for a number of years, but then by the time the 90s rolled around, NASA started getting serious about, okay, if there is an opportunity, and we have the funding, and the government's interested when things are doing well and they want to start a Mars program, we want to be ready for it. And that's where this book I was just talking about comes in and explains the story about how NASA prepared those plans and how they seem reasonable to the Bush administration. So that's the story about Mars exploration.
Okay. Well, thank you very much. I want to tell everyone who's listening, we're going to try and put it on YouTube. If we're successful, we'll send that link out to everyone in the AIAA Niagara Frontier section. And if you're not, then just look for it down the road, Bill Barry, AIAA Niagara Frontier section. We had a couple of people type in. Some of you are aware Dr. Barry was supposed to speak to us in person last month in March, but couldn't because of COVID. So we're hoping we have the opportunity to bring you back in person sometime down the road. This talk went really, really well, and we're going to be scheduling some more online talks, hopefully, until we can all meet in person again. So thank you very much, Dr. Barry.
My pleasure, Walter. Thanks for inviting me.
Okay, and everybody, thank you for tuning in. Take care.